So when we look at enthalpy changes, okay, enthalpy changes, okay, we are going to look into two types of enthalpy change. One is going to be endothermic, and second one will be exothermic. Okay, so you have I have written it here. Okay, so we have exothermic reaction, and we also have endothermic reaction. So let me actually have someone to explain to me. Okay, Jonathan, can you explain to me what do you understand about exothermic reaction?
In exothermic reaction, the energy is given out. Then in endothermic reaction, it takes in the energy from the surroundings.
Okay, so the heat energy is given out to the surrounding, and this one is the heat energy is
Taken in.
taken from taken in from the surrounding. Okay, so this one we assume that we have a beaker. Okay, so this is going to be a beaker. Okay, so the heat energy is going out, heat energy is going in. So now, okay, now if let's say I put my hand or any kind of a instrument, for example, a thermometer, okay, or I actually told you that if I put a hand, okay, if I put a hand over here, what will you feel? Okay, what will you feel? Is it going to be hot? Is it going to be cold? So for exothermic reaction, Clienta, can you tell whether it's going to be cold or hot?
Exo hot, endo cold.
Yes, so hot, endo is cold. So it means that if you refer to the thermometer, the temperature is going to rise. Okay, it's going to go up, and the temperature here is going to go down. So this is very, very important. And if you look at the enthalpy profile diagram, okay, so this is enthalpy profile diagram. So this one is measuring from, okay, let's say the enthalpy for the solution itself. Let's say you have a solution. So before reaction, so you put the reactants, okay, you put the reactants, and then they have a certain energy level. Okay, this is the energy level. And then after you react, okay, suddenly the energy level went lower. Okay, the energy level went lower. So it means that, okay, this energy is going to be given out or given in or taken in. So Newan, can you actually explain? Here for this diagram, the heat energy is given out or taken in.
Given out.
Okay, given out. So you can see from higher energy going to the lower energy. So of course the heat energy is going to be given out. So Kiara, can you help me with the enthalpy change? This is triangle H. I already told you triangle shows us change. H is going to be enthalpy. So is it going to be positive or negative?
Negative.
Okay, very good. So it's a negative. So this one, is it going to be exothermic or endothermic? So can Drew tell me?
Exo.
Okay, so this is going to be exothermic. So the same thing, if you look at another diagram, so if this is going to be another diagram, but the difference is, okay, you have the reactants at the lower energy, and then the product, after they react, okay, the higher, it's going to become a higher energy. So what happens here is the energy is going to be taken in, or energy is being absorbed. Okay, the energy is going to be absorbed. So delta H over here is going to be, can you tell me about the delta H? Is it going to be positive or negative?
Delta H positive for endothermic reaction.
Yes, so this one is going to be endothermic. Now, so this is going to be, these two graphs are going to actually tell us about endothermic reaction and exothermic reaction. So it's a profile, okay, the enthalpy profile diagram. So if you want, they ask you to draw enthalpy profile diagram, this is going to be the diagram that you will draw. Now, if this is going to be just enthalpy profile diagram, but sometimes you do have, okay, a situation where you have like this. I'm very sure you have seen this. This is going to be reactant, this is product, and then let's say if it is something like this is going to be reactant, this is product. Okay, this enthalpy profile diagram, okay, is the same as for this. It's just the same. they didn't include for this one, they didn't include one thing. Okay, what is one thing that we are talking about? Is something like, what is this? Suddenly, it means for now, okay, if I put it here, this one and this one, if you look at enthalpy profile diagram, okay, it is just going to tell us this is going to be exothermic. It's the same. It's the same. So if you look at the reactant over here and then the product over here, because it's going up, okay, it's going up. So this is going to be delta H, which is going to be positive. So it's going to be endothermic reaction over here. So this one, if I put it down, so this one is going to be delta H is going to be negative. Now, the difference over here is this diagram tells us or give information about what? Annabelle, can you tell me this particular diagram, if you compare with this enthalpy profile diagram, there is an additional information that is given. So what is the additional information that is given, Annabelle?
Activation energy.
Very good. Okay. So this diagram is still the same. Enthalpy energy level diagram, enthalpy profile diagram, whatever pathway. Okay. Don't care. Okay. If you want to just, if let's say you want to show activation energy, this is the diagram that you must draw. But if you don't have any data about activation energy, you can always draw this. No harm in this. So, but do remember the name that we use is going to be enthalpy profile diagram. Okay, enthalpy profile diagram. This is actually found in the book, but previously, I'm very sure that you actually have learned this. Nothing
Sir,
changed. Yeah. Yes.
uh, what do you mean by enthalpy profile diagram, sir? Which one is it?
It's the same.
The
It's a
one
graph.
with the activation energy, or both of them is called
Both.
enthalpy?
Okay, they are called, okay, they can actually be called in many ways. Graph of energy, enthalpy profile diagram, energy profile diagram. Whatever that they meant, they are actually meaning this one or this one. Okay, they might be meaning this or this, both also correct. But you need to actually draw the most suitable one. Let's say in the question, they have given you activation energy. So the best diagram that you should draw is going to be this. Doesn't matter what name that they give, because you know the value of activation energy. But if you do not know the value of activation energy and the question didn't bother about activation energy, then this diagram will be suitable. So it doesn't matter, it's still the same thing. So don't get actually confused with, oh, energy level diagram, enthalpy profile diagram. What is that? No need to worry about that. Okay, so you choose which one that is suitable. Okay, both also suitable. Okay, both also suitable. But this one in this chapter, this is given in the textbook. Okay, under what? Under enthalpy profile diagram. Okay, so here, if I want to actually talk about activation energy, okay, EA, activation energy, the activation energy is going to be, but before I go into that, okay, still the same, okay, the graph, if you draw the graph, the axis here, the y-axis is going to be enthalpy, not enthalpy change here, the enthalpy, okay. So this one is going to be not delta H, it's going to be H. This is going to be the change from this enthalpy to this enthalpy. So don't go and put delta H over here. It's H, enthalpy, yeah, enthalpy. And then this here is going to be progress of the reaction. And it's the same. It's the same as, okay, in the previous one, okay. H is going to be enthalpy, and then this one is going to be reaction pathway, okay. Progress of the reaction is still the same. Okay, so whatever that you want to use, please use it. Okay, you can actually say reaction pathway, what kind of path they take, but what kind of progress is still the same. Okay, so this one take note. Okay, but I want to actually highlight which one is the activation energy. Activation energy. Okay, let's actually, before that, let's actually find out more about what is meant by activation energy. Ashley, can you tell me what is activation energy?
Activation energy is the energy required for a chemical reaction to occur.
Yes. Okay. Not only energy required, because energy required is very general. Okay.
Hello?
Because for any reaction, yes, you require energy. But whether, like for example, it's like activation energy is like the cutoff point to get A, for example. Okay, let's say to get A, you get 80%. So students can get a lot of marks. Some of them can get 90, some of them can get 92, some of them can get 20%, some of them can get 30%. So not all of them, okay, will actually get A. So in this case, okay, the activation energy means, yeah, yes, that's the point that you need to take note. Okay, activation energy is the minimum energy, okay, minimum energy required to for the reaction to occur. Okay, or minimum energy required for the reaction to happen. Okay, because okay, sometimes when you put the reactants, okay, they don't react. But okay, sometimes you put certain reactants, they react immediately. So why suddenly sometimes you have some reaction not reacting immediately? Sometimes they do react very fast. Okay, so all these are depending on the activation energy. So sometimes the energy that they have on their own is not enough to start the reaction. So sometimes you need to heat them, so the reaction will continue. So something like that. So it's a minimum energy, and then this minimum energy we can actually change. Okay, this one we will learn in the some other chapter, reaction kinetics. It will change. Like for example, 80% is the cutoff point, but let's say the test is so difficult, so no one is getting A. So I bring down the 80% to maybe 70%, so that I get more people getting A. So how do I do that? So there will be some changes that will be done. Like for example, how do you decrease activation energy? Maybe you can use catalyst. Okay, so all these are going to be the one that is over there. But again, if you want to calculate or if you want to show activation energy, the activation energy is always from the reactant to the top part. This is going to be your activation energy. Always from the reactant to the top part. That's going to be your activation energy. So I don't want to focus on this chapter because this one is under different chapter. So coming back to this, okay. So this is going to be enthalpy profile diagram. Okay, enthalpy profile diagram. You won't be expected to see any kind of activation energy or any term for this chapter. Yeah, for this chapter. But later when you do like AS revision questions and so on, yeah, you will actually have all this because it's part of AS. So I'm just introducing as well. And I'm very sure you have learned this before. So coming back, okay, coming back to exothermic reaction and endothermic reaction, let's actually recall whether you can remember some reactions involving exothermic and involving endothermic. So maybe we can start with maybe who are James. James is not there, no video. Okay, Justin, we'll wait for James. Justin, while waiting for James.
Exothermic, right?
Yes,
Combustion.
yes, any kind of
Neutralization.
combustion. Yeah, wait, Justin. Any kind of combustion is going to be exothermic. What else, Justin?
Neutralization, right?
Okay, any kind of neutralization, acid and base is going to be exothermic as well. Number 3. If you don't remember, we can pass to someone else.
Is it? Can I guess first?
Yeah,
is it
can.
Decomposition or no?
No.
Oh, okay. That's
Decomposition
endothermic.
will come under endothermic.
Okay.
Okay, so this one I'll put it over here, decomposition. So decomposition, there are 2 examples based on yesterday. I think decomposition of nitrates or any kind of decomposition of carbonates. Yesterday, we actually went through this example. Okay, any kind of decomposition, like for example, if I write equations, like for example, magnesium nitrate, when they decompose, they will give you magnesium oxide plus nitrogen, NO2. Okay, magnesium oxide plus NO2, and another one is going to be O2. Okay, this is going to be decomposition of nitrate. Okay, but decomposition of carbonates, let's say calcium carbonate, when they decompose, they will give you calcium oxide plus carbon dioxide. So this is some of the reactions. So any kind of decomposition, decomposition means is trying, you have a compound and they break into something. Okay, they break into something. So one compound, they break into multiple things. Okay, so that is going to be decomposition. In our chemistry syllabus, we will focus on two types of decomposition most of the time. Okay, nitrates and carbonates, and those examples are there. Yeah, but we do take note as well. Okay, hydrogen peroxide, H2O2. Okay, H2O2, they can also change into H2O plus O2. Okay, and this is also called decomposition. Okay, therefore this is also going to be counted as endothermic, even though we don't actually learn it under the examples. But do take note, all decomposition reactions are going to be counted under endothermic. Yeah, so the same thing here, all combustion, okay, any kind of combustion with oxygen give you carbon dioxide and water, giving you carbon monoxide and water, like for example incomplete combustion of hydrocarbon, okay, or giving you carbon, okay, carbon and water is also going to be, they are also going to be known as combustion. Even combustion of any kind of burning of fuel, or burning of ethanol, anything related to combustion is going to be counted under exothermic. Okay, neutralization, I think you should know. Okay, if you have HCl with NaOH, it's neutralization. Okay, if you have H2SO4, okay, with KOH, okay, it's also neutralization. Any kind of neutralization, neutralization is a reaction that gives you salt and water. Okay, any reaction where acid reacts with alkali, give you salt and water, then the reaction is going to be neutralization. And take note, there is another reaction also for exothermic, like for example, if you have metal, okay, metal plus acid, okay, metal plus acid, they give you salt, okay, and hydrogen gas. Now, this metal plus acid gives you salt and hydrogen gas, like for example, magnesium plus HCl. They give you magnesium chloride plus H2, okay? And this reaction is also going to be categorized under exothermic reaction, yeah? So, Josh, can you tell me, how do we test for hydrogen gas in our lab?
Using a lighted splint, then
Yeah?
there's going to be a pop down if there's hydrogen.
Yes. So by using a lighted wooden splint, it will give you a pop sound. Okay, since I actually brought that up, how do we actually test for oxygen then? This is oxygen. How do we test for oxygen? Kenneth?
Glowing splint.
Kenneth,
It's like
Kenneth. Sorry,
not
sorry.
lit, like
Yeah.
just the embers.
Yeah, again, okay, yes, okay, it's going to be still, okay, by using glowing wooden splint. So if you use glowing wooden splint, it is going to be relighted. Okay, relights glowing wooden splint. It's okay, Kenneth. I will ask you about this carbon dioxide. How do I actually test for carbon dioxide, Kenneth?
We use quick lime.
With use of? Your voice is breaking. Or is it my internet connection?
My internet is unstable.
Okay, so now it's okay.
We use
How do you
quicklime
test for
also.
carbon dioxide?
Quicklime or lime water? I forget. Lime water, I think.
It's lime water. Okay, it's lime water, not quick lime. Yeah. So this is going to be you test with lime water. Okay. So if you test with lime water, the lime water change into cloudy or milky. Okay. So this one is going to be lime water. But talking about that, okay, later I will actually go into that. Okay. So let's actually go further. Okay. Number 4. What are going to be other examples? Angela, do you have any other examples? I think I gave five reactions yesterday. exothermic reaction?
I don't know.
Respiration.
Angela first.
I don't know.
Okay, just now who tried? Anyone just tell? Just now someone
Respiration.
mentioned. It's not lagging, yeah. I'm just waiting for someone to tell me the answer.
Respiration.
Yes, okay. So it's respiration, okay, respiration, any kind of reaction, okay, where they actually try to break down the glucose to give you energy, okay, whether it's going to be anaerobic respiration or aerobic respiration, this one more towards bio, yeah, but again, aerobic respiration is by using oxygen. Anaerobic respiration is going to be like yeast trying to use glucose to make ethanol, okay, alcohol, okay. All these respirations, okay, they are counted under exothermic reaction. Now, so that is respiration. How about number 5? Name one. Number 5. Can you think about other?
I don't remember any more for exothermics.
Okay, anyone else?
I think crystallization, is it? No.
If it is crystallization, yes, possible. Okay, because I think one of the example that I gave yesterday, okay, when you have copper sulfate is aqueous, and then they want to change it to solid. So aqueous means liquid, they keep on moving. So when they actually become solid, they still remain in one place, so the energy is given out. So it's going to be exothermic as well. So crystallization is going to be one of the example. Okay, crystallization of copper sulfate is going to be exothermic. So anything else? Something that mentioned by Kenneth just now when he mentioned about lime water, then he mentioned about something.
Is it dissolving calcium oxide and water?
Yeah, the reaction of, okay, quicklime. Okay, quicklime is calcium oxide. So quicklime with water. Okay, quicklime with water, they are going to actually give you exothermic reaction. So what is quicklime? Okay, quicklime is calcium oxide, so plus water. They are going to give you calcium hydroxide. Now, so do remember quicklime is calcium oxide. Okay, calcium oxide. Now, this calcium hydroxide, one of the name is going to be the, you know, the test of lime water. Lime water is going to be calcium hydroxide. So it is also known as, okay, calcium hydroxide is also known as lime water. Okay, it is also, this one is quicklime. There is another name for calcium hydroxide, but if it is going to be lime water, if it is going to be in liquid form, okay, so or with water, okay, it's going to be lime water. But if it is going to be in a solid form, okay, there is another name. Can someone remember that, Erling?
Slaked lime.
Yes, good. Okay, it's called slaked lime. So slaked lime is used, okay, to improve the pH quality of soil. Okay, so they actually put slaked lime. Okay, slaked lime is there. Okay, so this one is going to be some of the information related to exothermic reaction. Okay, all the, I think some of the important examples, okay, involving exothermic reactions. Okay, now if you look at endothermic reactions, okay, I have actually went through one. Okay, one is going to be decomposition of nitrates and carbonates, okay, or any kind of decomposition is going to be endothermic. So let's actually look at some other examples. Can you give me some another 2 more examples related to endothermic reaction? Let's actually ask someone here, maybe Maybe Kendrew. Give me one example.
What's the question, sir?
Give me one example, okay, related to endothermic reactions. So I have actually given one, decomposition of nitrates and carbonates. So this one you should be actually taking down notes, okay? So did you guys take down notes? Davis, can you answer this?
Photosynthesis.
Again?
Photosynthesis.
Photosynthesis, yes, okay, but I didn't discuss, but it's okay. Yes. Photosynthesis is actually using the sunlight. Okay, they are trying to gain the energy. Yes, it's endothermic. Other examples? Nevan, can you remember?
Baking soda and vinegar, yes, sir.
Baking soda and vinegar. Okay, which is going to be, I think I mentioned about sodium hydrogen carbonate with baking soda and vinegar. Maybe we'll check, but anyway, it's actually sodium hydrogen carbonate reacted with citric acid. So I think the baking soda and vinegars sounds the same as well. Yeah. So anyway, sodium hydrogen carbonate with citric acid is going to be one of the example that I mentioned yesterday. Why I mentioned yesterday, because it was found in the textbook. Yeah. So this one you need to know. And another one, okay, Jonathan, can you remember another one? Something to do with NH what? Anytime when you have ammonium salts, when you dissolve in water, any kind of ammonium salt, okay, when you dissolve in water, that is going to be endothermic. So do remember, when you have all these reactions, okay, if you go and I think the main idea over here is when you have all these reactions, okay, when you actually add them, okay, if you have them in a beaker, okay, and then you mix, okay, or you let the reaction to take place, when you go and touch the beaker, okay, what we expect to feel, we expect to feel cold. Why you feel cold for that? Because the heat energy from your body is going to be taken into the solution. So your body is going to be the surrounding. Again, okay, the surrounding. So they will absorb the energy. So this is going to be endothermic reaction. So the idea for any kind of reaction that is going to be mentioned over here, okay, from number 1 to number 6 over here, this is going to be if you have a beaker, okay, if you have a beaker, and then, okay, you go and you happen to go and touch it, okay, so you will feel it's going to be hot, okay, you will feel it's going to be hot because why? Because the energy is going to be given out, okay, given out. So when you feel the heat, okay, your hand, okay, is going to actually feel warm. So therefore, this is going to be an exothermic reaction. So this is the summary of what we have learned until now. Yeah. So enthalpy change. So is there any question?